We're given policyholders following history. We want to conduct a mortality study from January 1st, 2012 through December 31st, 2012 using actual ages. And we want to calculate the absolute value of the difference between the estimated mortality probabilities at age 82 using the exact and actuarial methods. So the key here is we want to use the actual age. So if we're looking at when the policyholder will turn 82, because that's where we're looking for the mortality, so we're basing this off the actual age, so the date of birth. So it's going to be 82, the first person, on April 1st, and then 82 years after they were born, so that will be 2012. The second policyholder will be July 1st, 2012. Third policyholder, that's 82 years after August 1st. And then 82 years after September 1st. So that's step one. Now we have an idea, okay, for the exposure, if we're using first the exact, so we're looking at the exposure for age 82. Well, how many months was the first policyholder 82 years old? Well, he started 82 years old April 1st and then died on October 1st. So that's 6 months that the policy was active at age 82. The next one, the person is still insured on December 31st, 2012. So the policyholder turned 82 years old July 1st and remained active until the end of the year. So that's 6 full months of age 82. Same thing with the third policyholder. He's active, or he's still insured on the end of the year, and he turned 82 August 1st. So from August to September, that's going to be 5 months. The last policy number, he turned 82 on September 1st and surrendered on November 1st. So that's only 2 months that the person was 82 before surrendering. And we're going to divide this over 12 because we want this in terms of years. So it's months per year. So that's going to be 1.5833. Now we do the same thing, but we're using actuarial approach. And for this one, the only thing that changes with actuarial method is whenever we count death, we count it a year after. So we count at the end of the year, basically. So for the first person, because they die, we're going to give the exposure as 12 for that. But everything else will stay the same. So we get 2.0833. And for both of these, the number of people that died at age 82 is 1. And that's the first policy number. So now we can estimate the mortality probabilities at age 82. So for exact, we're going to be using the formula. So it'll be Q82 is 1 minus e to the negative d over e. So number of deaths divided by exposure. I guess this one I should just put 82. So deaths we said was 1. Exposure was 1.5833. It'll give us 0.4682. And for actuarial, it's just going to be the number of deaths divided by the exposure. Number of deaths was 1. Exposure was 2.0833. And that's 0.48. We want to find the absolute value of the difference. So we just subtract these. And my answer is 0.012. Okay, now we're going to be looking at a similar example, except we're going to be looking at the nearest birthday. So this one's going to be a little tricky. So we want to see when the person turns 82. And the study is between January 1st, 2012 to December 31st, 2012. So the birthday is going to be the same month and day as the day was issued. So for the first policy number, the date of birth was April 1st, 1930, and it was issued on March 1st, 1980. So in 1980, so the person March 1st, 1980, that's right before their 50th birthday. So it's like 49 years and 11 months. So we're going to use a nearest birthday. And so we're going to treat the date of birth as 3/1/1930. So this will be like 3/1. And so the person will turn 82 3/1/2012. Okay, the second policy number, it was issued October 1st, 1990. So at that time, the person was 60 years old and 3 months. So we're using the nearest birthday when the policy is issued. So we're going to use, instead of July, we're going to use October. And so the person will turn 82 on October 1st, 2020, or 2012. Okay. Now for the third person, so their date of birth was August 1st, 1930, and it was issued on January 1st, 2000. So on January 1st, 2000, the person was 69 years old and 5 months. Okay, so this is very crucial here. So 69 years old and 5 months. So does it make sense to have the policy issued January 1st, sorry, not issued, the birthday, when the person will turn 82. Does it make sense to have the person turn 82 January 1st, 2012 or 2013? So that's the question right there. So let's rewind here. The person on January 1st, 2000 was 69 years old and 5 months. So we're going to treat that person, instead of being 69 years old and 5 months, we're going to instead say that person was 69 years old. So, and I guess this should be January 1st, 2000. Had it been 69 years old and 7 months, we would go back. We would say it should be 1/1/2012 as the birthday, as the age that the day he'll turn 82. So because he's only 5 months away from the policy issued, we're going to use January 1st, 2013. So this step is crucial. It's a little confusing. So there's 5 months until the policy issued. So I guess let me try to draw like this. Let's say 1/1/2000. Or I guess we can use the birthday. So we can say 1/1/1931 or 1/1/1930. Okay, so let's say he was born on August 1st, 1930. So that means here he'll be 5 months. Versus here it's 7 months. Okay. We want the nearest birthday. Well, what's near? Is January 1st, 1930 or January 1st, 1931? Well, obviously 31 because that's only 5 months. So we're going to treat this as January 1st, 1931 as the birthday. So then if we add 82 more years, the person will turn 82 on January 1st, 2013. Okay. And then last policy number, let's see. Person was born September 1st, 1930. So August 1st, 1930 will be the birthday. That's only a month apart, so that's definitely the nearest birthday to the policy issued. And so we'll just add 82 years for that. We'll get 8/1/2012. So now we have all the information, all the age. So all the dates when the person will turn 82. So we want to keep in mind that our study is between January 1st, 2012 and December 31st, 2012. So now we want to look at the exact method. So the exposure 82. Let's see. The first person turned 82 on March 1st and died October 1st, the same year. So that's 7 months. The second person turned 82 October 1st and is still insured at the end of the year. So that's 3 months. So October, November, December. Okay, the third person turned 82 on January 1st, 2013, which is really the end of the study. The study is December 31st, 2012. So it's like the day after, really, the person is 82. So during 2012, the person was 81. It was not 82 years old. So there's no exposure. And the last person turned 82 August 1st, 2012, and then surrendered, let's see, 3 months later. Okay. And that's going to be over 12. So we get 1.0833. Now for the actuarial method, the only difference again is the death. So we count death at the end of the year, so that's going to be 12. And everything else is going to be the same. And there's only one death, which is the first policyholder. And now we just use a formula. So for the exact method, so Q82, that's 1 minus e raised to the e to the negative 1 over the exposure. So that's 0.6027. So for the actuarial, that's just the number of deaths over the exposure. So that's 0.667. So we're going to take the difference there. We'll subtract, take the absolute value. We get 0.064 as the final answer. Okay. All right, last problem. So this one, again, will be similar. Okay. So let's see. We're doing a study from anniversaries in 2012 through anniversaries in 2013. And we're using the nearest birthday. So this is kind of like the last problem. So we'll use the same information as above. So I'm just going to copy everything down. So that's all the same. Okay, so we're going through the anniversaries. Okay, now the first person turned 82 March 1st, 2012, and died, let's see, October 1st, so that's 72. Oh, sorry, that's 7 months. Okay. Now the second person, so they were issued they turned 82 October 1st, 2012, and surrendered May 1st, 2013. So that's 7 months. So the next person was, turned 82 January 1st, 2013, and kind of same logic as the last problem. There's 0 exposure. Last one, person turned 82 August 1st, 2012, and then surrendered 3 months after. So that's 3 months. And that's 1.4167. Now for the actuarial, so this was exact. For actuarial, everything's going to be the same except the death is treated at the end of the year. So that would be 1.833. Now we just use a formula for Q82. So that would be 1 minus e to negative number of deaths over exposure. So 0.5063. So this was using the exact. And then for the actuarial, it's the number of deaths over the exposure. And that's 0.5455. We look at the absolute value of the difference. And we end up getting 0.039.